Okay, we're going to try and prove this difference identity. When you take the cosine of two angles subtracted, it equals the cosine of the first and the cosine of the second angle plus the sine of the first times the sine of the second angle. And it always works. We did a little exercise where we showed it worked for three pairs of angles, but even if you showed it worked for 100 times, it wouldn't be a proof. Now we're going to prove it. What do we have to do? We have to make this circle here that's got a radius of 1, stops at A and B, and going up to B, we call the angle alpha beta, and going up to A, the angle of inclination there is alpha. And the difference, angle AOB, would be alpha take away beta, alpha minus beta. Well, now we understand that diagram, we can just move right along here. So let's try the first step. Use the cosine rule to find an expression for the length AB. That's the first thing we're going to do. You could pause it and see if you could do that. And if you know, so you can pause the video. Well, I'll show you how it works. All you do is the cosine rule. You need two sides and an angle in between. And you just square the two sides, add them together, minus the two sides multiplied together, times the cosine of the angle in between. Well, 1 squared plus 1 squared is 2, and 2 times 1 is 2. There's an expression for AB squared. Let's look at the next part. Express the coordinates of A and B in terms of sine and cosine. Well, how can we do that? Let's just imagine a little triangle right here up to B. That 1 is the hypotenuse. The x-coordinate would be the adjacent side. So the x-coordinate over 1 would be the cosine of this angle. So the cosine of beta is the x-coordinate of B. And the y-coordinate would be the opposite over the hypotenuse. The y-coordinate would just be the sine of beta. And that's what you have. B is just cos beta, sine beta. And for the same reasons up here with A, if we made a triangle down there, we can see that the coordinates of A are cos alpha and sine alpha. And that's now we have an expression for the coordinates in terms of cos and sine. Now, the third step, you could try and do it on your own, but here we go. We're going to find another expression for AB, the same length, but we're going to use the distance formula and these coordinates, cos alpha, sine alpha. You just do that. So that's all you do. You subtract the two x coordinates and square it, subtract the two y coordinates and square it, you get AB squared. FOIL it all out, you're going to get cos squared, and you're going to get a sine squared here. You're going to get another cos when you multiply this out. Anyways, you're going to get sine squared plus cos squared alpha. You're going to get sine squared plus cos squared beta. And that's going to be 1 and 1. That's just going to be 2. And what are you going to have? You're going to have minus 2 cos alpha cos beta and minus 2 sine alpha sine beta. Well, just factor out the negative 2 there, and there you've got it. Negative 2 cos alpha cos beta plus sine alpha sine beta. Hey, that's starting to look like our formula. Now, all you do, we have two ways of looking at AB squared. You just make them equal to each other. And then see if you can end up with this formula that we're trying to figure out. Well, this is what it's going to look like. All you do, make the two things equal to each other. And there we have it. And then subtract 2 from both sides. Divide both sides by negative 2. Hey, that 2 and that 2, hey, it just all cancels. And you're left with cos alpha minus beta equals cos alpha cos beta plus sine alpha sine beta. That sine beta, that formula, that's the thing you've got in your formula sheet. There's the whole thing all done. It's kind of worth going through it and trying to figure it out because it makes you think about all sorts of algebra and trigonometry, and it's just sort of good to work with, I think, anyways.